let's determine the partial fractions of 3 over x plus 1. Okay, so here we've got two factors, which are x and x plus 1, making up the common denominator. Okay, so we can have letters a and b represent the numerators, and then find the values of a and b. So look at the right hand side. We can come up with a common denominator, which will give us again x and then x plus 1. Just multiply the denominators we have, and then after you divide by x, what remains is the other part, x plus 1. So you have a multiplying by x plus 1, and then the other part you have b multiplying by x, right? So now our goal is to find the values of a and b. So remember, this is equal to that, right? The denominators are the same, so we need to equate the numerators. So we have 3 being equal to ax plus 1, or I can actually go direct by multiplying what we have. So a multiplied by that, we have ax plus a, and then we just have our bx. So we have 3 being equal to ax, and then plus bx, and then plus our a, right? So in this case, it becomes easy, because what we basically have is the fact that our a is the only constant, okay? And then this side we only have 3 as a constant. So directly we can see that our a is equal to 3. Now for this part, we don't have any part attached to x, so we can introduce a 0x there. Okay, so if that's the case, then we expect that a plus b, of course after you factor it out, if you factor a plus b, you factor out x, sorry, you remain with a plus b. So the a plus b should be equal to the 0, right? So a plus b should be equal to 0 because they are the ones attached to x. So now our a is already what? Our a is 3. So therefore our b is going to be what? Negative 3. Okay, so we found the values of a and b. So our a is 3. So 3 over x, and then our b is negative 3, and then over x plus 1. So that's basically how we determine the partial fractions here. So how basically do you get to split this into its partial fraction? So how do you basically take this into its partial fractions? So it's very basic. So look at what we have in the denominator. So we're going to have two different denominators, x plus 2 and then x minus 1, and then we just add, and then of course we just put our letters of choice on top. So I have a there and b there to represent that. Okay, so we'll take it as though we are solving on the right, and then what do we get to have? Let's have a common denominator, so we end up multiplying them again. Okay, so divide this into what we have. The result will be x minus 1. So end up a multiplying by x minus 1, and then for that part, if you divide that, what remains is this part. So you end up having b multiplying by x plus 2. So don't forget, we have 2x plus 1, and then over x plus 2, and then x minus 1. So at this point, what we're saying is the denominators are equal, so we can equate the numerators, right? So for the numerator, what do we have? So we have 2x plus 1 being equal to, so let's just actually get to distribute. So a times x, it's ax minus a. For the other part, it's bx plus 2b. Okay, so what do we have? So let me correct the like term. So I have ax plus bx, and then we have 2b minus a. And then this other side, what you have is 2x plus 1. So we need to find the values of a and b. So I can easily substitute, or I can easily factor out the x there. So if we do factor out the x, what do we have? So we have a plus b, and then x is common, right? okay, equal to 2x plus 1. So at this point, if whatever we have is true, then the part having 2x should be equal to the part having x there as well. So we now have 2 being equal to a plus b, and then this constant that we have 1 should also be equated to the parts that are not having any x on the other side. So 1 is also equal to 2b minus a. Okay, so I can now use basically take them to be simultaneous equations. So I can make my a to be the subject in this formula. So we end up with 2 minus b equal to a, and then I can substitute in the other equation 2b minus the a. So for the a we have 2 minus b, and then our 1 is equal to 2b minus 2 plus b. 2 comes the other side, we have 1 plus 2 equal to 3b, and then our b essentially becomes 1, and then if our b becomes 1, we have now 2 minus 1 being equal to a. A is also, a becomes what? We're finding a to be 1 as well. Okay, so here we made a the subject, we had 2 minus b, and then from that point we went to this other equation where our 1 was equal to 2b minus a, and then we had to substitute where we had our a, we put 2 minus b. Okay, and then 2b plus b gave us 3b, this gave us 3. Okay, so this is basically what we have. A equal to 1, b equal to 1. So you might want to prove if it's true. So you have a common denominator, x plus 2, x minus 1. So if you divide, you're going to have x minus 1 for the first part. Multiplying by 1 will just be that. And then as well there, x minus 1 give you x plus 2. Multiplied by 1 it will just be itself. Right? So if you basically get to add them, x minus 1, x plus x, they are going to have 2x. And then negative 1 plus 2 is just going to be a 1, which is actually now equals what we have on the left hand side. So how do you basically get to determine the partial fractions of 1 over x minus 1 squared and then x plus 1? Okay, so each time you have a power of 2 or higher as a denominator being multiplied by another linear denominator, we call this a repeated factor. Okay, so what basically happens is you would have to expand this one to the power of just 2 itself. So in this case we're going to start from the minimum of the 1. So we're going to say the first factor we're going to have is x minus 1, and then plus the other denominator we're going to have is now x minus 1 squared itself. This is what repeated factor works like. And then of course we'll add the other one, which is just x plus 1. So we can introduce now letters there, a, b, and c. Okay, so you know what that means, right? So if you add the power 3, it would mean we'll have x minus 1, x minus 1, x minus 1 3 times, right? So it will be have 1, 2, and 3. That's one thing that's important about repeated factors. Okay, in this case let's proceed. So what we have, so of course when it comes to the common denominator, this and this have got a common denominator, which is just x minus 1 squared, right? Because they cannot be divided into x minus 1 squared, and then x plus 1. So essentially it's taking us back to whatever we had from the start. So what we're interested in is the numerator. So let's basically get to divide. So if you divide this into this 1x minus 1, because one thing that you need to picture is x minus 1 squared is x minus 1 multiplied by x minus 1 again. So if you divide by just 1 remains, right? So we're going to have a multiplying by x minus 1, and then also the other one is also remaining, x plus 1, and then plus b. If you divide b has got x minus 1 squared, so all this will disappear, and then we just remain with x plus 1 remaining, right? So we have x plus 1, and then we now have c. So for c, if you divide x plus 1, what remains is this other part, x minus 1 squared. Okay, so since the denominators are the same, we just have to equate the numerators. So for the numerator, we just have like a 1, okay, and then being equal to a, what do we have? So we have a, x minus 1, x plus 1, plus b, x plus 1, plus c, x minus 1 squared. So let's try to find the values of a, b, and c. Okay, so how do you go about this? So this is going to be fun and straightforward. So let me use elimination method before we use the substitution part. Okay, so we can eliminate one of them, two of them, and find for the other one. So I know that if I put a 1 where there's x, all the parts having x minus 1 will disappear. So let's do that. So let our x be equal to 1. So if x is equal to 1, this part will become 0, and the entire a will disappear. So this will disappear, and that will also disappear. So the only part that remains is 1 on the left, 1 is equal to, and this part, which will be 2 now. X plus 1, 1 plus 1, 2, so we have 2b. So giving us a b value of 1 over 2. So the other value we can perform is using negative 1. If we add negative 1, this part will give us a 0, so a will disappear again, and then now b will also disappear because we're adding a negative 1. Only that part will stand out. Negative 1 minus 1 will give us a minus 2. Okay, so we now have on the left 1, and then c, negative 1 minus 1 will give us negative 2 squared, right? So negative 2 squared gives us a 4, so 1 is equal to 4c. So c becomes 1 over 4. Now you notice, is there any other way of eliminating any part? We can't eliminate any part. At this point we can't. Okay, because we've already used both 1 and negative 1. So there's no way we're going to find the value of a using the same method. So what do we basically do? So what we can do at this point is basically get to expand this. Okay, the fastest way I can do it is, I know that this is going to be equal to, so x minus 1, x plus 1, that's actually a difference of 2 squares. I can just say that is just x squared minus 1. And then there we can distribute. We have bx plus 1. We have, for that part, we have c. And then x times x is x squared minus 2x plus 1. You know how to expand that. So our goal here is to find the value of a. So I can just get the part having x squared, right? So on this side, on the left side of the equation, we don't have anything. So this is the part where we now introduce a 0, right? So we can have an imaginary 0x squared. And then for the a, we have ax squared. And then for the c, we have cx squared. So the x squared can just basically divide. So we have 0 being equal to a plus c. Now our a is what we're trying to find. Our c is 1 over 4. So we have a plus 1 over 4. So if we subtract both sides, minus, or we add negative 1 over 4. So our a basically becomes negative 1 over 4, because it's the only value you can add to 1 over 4 to get a 0. So therefore the partial fractions becomes, so for a we have negative 1 over 4, so x minus 1, plus our b is 1 over 2, so x minus 1 squared, and then for our c 1 over 4. So this is what we have as our partial fractions. So how do we split x to the power 3 over x squared minus 4 into partial fractions? So this is a case where you have the higher power divided by a lower power. So this is now where you have to handle long division first of all. So let's divide our x squared minus 4. Okay, so we'll divide that into x to the power 3. So the way we divide is we just use the highest power of the divisor, which is x to the power 2. So x to the power 2 into x to the power 3, we have a difference of x, and then x times x squared is going to be x to the power 3, and then x times negative 4 is going to be minus 4x. So, okay, we can now find the difference. This and this will subtract, right? And then we don't have anything there, so we can introduce an imaginary 0x. 0x minus 4x gives us a positive 4x. Right, that's what we have at this point. Can we go any beyond this point? No, because we can't divide x squared into the 4x. So what we're going to have is this part being equal to, first of all, our value is x, and then the remainder is 4x over x squared minus 4. Okay. Now at this point, we can actually, in this case, since our denominator we were able to split it, we can have to go beyond this point. But if it was a quadratic part that you can't factorize, we're going to end at this point. So let's proceed. So let me focus on this part now. So we have 4x over x squared minus 4, which I know is the difference of two squares, so which can be expressed as x squared minus 2 squared, which will now give us x minus 2, x plus 2. Okay, so this brings up for partial fractions. So we can have a over x minus 2, and then plus b over x plus 2. So our goal is just to find the values of a and b. So if we find a common denominator on our right, we're going to have x minus 2 and then x plus 2. So we can do as wise. If you divide this into what we have as our denominator, we're going to get x plus 2. So a multiplied by x plus 2, and then the other part is going to be b multiplied by x minus 2. Okay, so at this point we know we can now equate our numerators, right? So our 4x there is going to be equal to, let's now distribute a times, that will be ax plus 2a, and then plus bx minus 2b. So we can now try to find the values of a and b. Okay, so if you check there, we have x, the part having x only, so we can equate it. 4x is going to be equal to, so we have ax and then plus bx. So the x can disappear, so that we have 4 is equal to a plus b. And then the other equation you can come up with is getting the constants. The other side we don't have any constant, so we can just take a constant to be 0. So we have a 0 being equal to 2a minus 2b. We can make a subject in this formula. We are going to have 4 minus b being equal to a. And then if we get our a and substitute there, we're going to have 0 is equal to, for our a we have 4 minus b minus 2b. So I have 0 is equal to 8 minus 2b minus 2b. So essentially we have 0 is equal to negative 2b minus 2b, that gives us negative 4b, and then plus 8. So we now have 4b being equal to 8, and then our b becomes 2. And then if we substitute there, 4 minus 2, our a also becomes 2. So what do we have? A2, B2. So if you've paid attention to what we've done, so at this point we have x, and then plus our a is 2 over x minus 2, and then plus 2 over x plus 2, since we split that into the difference of two squares, and then we found our values of a and b to be 2's. So this is what we have now as our partial fractions. So let's determine the partial fractions of 5x over x squared plus x plus 1 x minus 2. So we have a quadratic denominator which we can split. Okay, so if you can split it, it comes out in a way where you have two brackets representing the quadratic part, giving us two linear parts of it, in addition to the x minus 2, which is separate. And then this way, it's easy to handle it. It just becomes a plus b plus c, each divided by its own denominator. Okay. Now, in a case where you can't, we apply a different approach. So you take it as 1, which we are going to do in this case, because I don't think so we're able to factorize that. Okay. So what we do is we'll have a part for the quadratic denominator, x squared plus x plus 1, and then a part for the other linear denominator, which is x minus 2. So what do we have now? So now this is where you have to be careful. So what we do for the part for the linear denominator, we just put a constant. So we reduce by x. Since we have x to the power 1, we are going to have x to the power 0, that's why we have a constant. So since here we have x squared, we're going to reduce the denominator by 1, so it will become x. So we'll say ax, and then of course plus b. Okay, because even this x is also reduced by 1, which gives us a b, just a constant. So letters, we're just using letters to just help us represent the coefficients or the constants. Okay, this is the only new thing that you need to know about the integration, or what you need to know about the partial fractions. Okay, so let's take it from there. So if you basically get to take it as though you are adding these fractions again, you're going to end up with what we had on our left. Okay, with this giving us a common denominator. Okay, and then of course if we get to divide by that, what do we expect? So it's going to give us that. So we're going to have ax plus b multiplying by x minus 2, and then for the other part, this into that, we're going to remain with a c multiplied by x squared plus x plus 1. Okay, at this point now we can expand. Since we know the denominators are the same, we can equate the numerator 5x being equal to this part. Now let's now try to deal with this. So we can expand right away. Let's multiply by x. So x times ax will be ax squared plus bx, and then multiply by the negative 2. So we're going to have negative 2ax and then negative 2b, and then we have plus cx squared plus cx plus c. Okay, so this is what we have for the numerator, right? Okay, any parts having x squared, this part and that part. Okay, So they can help us form different equations just from there. So for the parts that are having x squared, we have a and c. On this part, we don't have anything, so I can introduce an imaginary 0x squared on the left. So we have 0x squared being equal to ax squared plus cx squared. So this x squared can disappear, so that we just have 0 is equal to a plus c. Okay? And then any part having x, so 5x is there, so we have 5x being equal to, and then on the right hand side this part is having x, so is cx, so we have bx minus 2ax and then plus cx. And then the parts having a constant, so we have negative 2b. On the left, of course, we don't have any constants, so 0 will represent the constants. Should be equal to negative 2b and then plus a constant c. So we have these three equations that are going to help us. Okay? So which one is the most simplified one? So this one. I can make C to be the subject there. Or I can just make A, since I can make C the subject in this other one. So for this one, we're going to have our A being equal to negative C. If we add the additive inverse on both sides, A becomes equal to negative C. And then this other equation, we can make C the subject, so we can add 2b both sides. So we have our C being equal to 2b, right? And then we can now have the other equation. The x can disappear. So what do we have? We have our 5 being equal to b minus 2a plus c. So how simply can we handle this? We can easily handle this by basically just substituting the parts where we have our c, right? So if we look at it from the way we've put it at this point, since our goal is to basically get to find one of them first of all. In this case, the only way we can do that is if we can make all the letters appear to be maybe, for example, a b. Okay, so let's take everything I think to a b form. So c is already equal to 2b, so c is already in the form of b, so we can make a to be in the form of b. So therefore I can take that one, my a is going to be equal to negative, so my c in terms of b is 2b. So therefore a becomes negative 2b. So therefore this equation becomes 5 is equal to b. For our a, we have negative 2b, so 2 negative 2b, and then plus c, which is 2b. So we have 5 being equal to b plus 4b plus 2b. So we have 5 being equal to b plus 4, 5b, 7b. So our b becomes 5 over 7. Okay. What else? We can now find our a. It's negative 2 times that. And then we can also find our c. It's 2 times that. So therefore our a is equal to negative 10 over 7. Our b is 5 over 7. Our c is 10 over 7. Okay. So we can now substitute at this point what we have. So our a is negative 10 over 7 plus our b, which is 5 over 7. So since we have a common denominator there, of course this is having x, we can write it in the form of negative 10x plus our b, which is just 5, and then over 7, which we can take to the denominator. So 7, and then 7x squared plus x plus 1, and then our c is 10 over 7 as well, so x minus 2.